Okay, so PbO2, this is problem number 10 from the homework assignment, goes to Pb2 positive. The leads are already balanced, so I will add 2 waters to the product side to balance out the 2 oxygens from the reactant side. Doing that adds a total of 4 hydrogen ions, so I'll go ahead and add that to the reactant side. And now I want to balance out my charges, so I have a positive 4 from the hydrogen plus a 0 from the lead. Likely that's lead 4 oxide rather than it being lead 2 peroxide, but we don't know for sure because we're not given a name. So this will give us a positive 4 on the reactant side. And then over here I have a positive 2 and a 0, so I get a positive 2 on this side. We're always going to add electrons to the more positive side to bring that charge down. So I will add in 2 electrons to get our overall charge on this side down to a positive 2 so that it matches my product side. So go ahead and clear that out to make this a little bit easier to read. And then the next one is I2. Goes to IO3 minus. And the iodines are not currently balanced, so I'll go ahead and put a 2 in front of IO3 1 minus to balance out my iodines. I now have a total of 6 oxygens, 2 times 3. And so I'm gonna have to go ahead and put 6 waters on this side, which introduces 12 hydrogen ions. And now I can go ahead and balance out my charges. So I have a 0 and a 0. And then I have 2 times negative 1, so negative 2, plus 12 times positive 1, so positive 12. And I have a positive 10. I'm going to go ahead and add 10 electrons to the more positive side so that both sides are now at 0. All right, so now when I compare, I have 2 electrons here and 10 electrons down on my second equation. I'm going to have to go ahead and multiply the top equation by 5. So I will do that next. So 5 all the way across. So 5 times 2 gets me to my 10 electrons. And then I have 20 hydrogen ions. Put a 5 in front of PbO2. 5 in front of here, and then 5 times 2 is 10 waters. So at this point, I'm going to go ahead and cross that off so I don't think about those numbers anymore. I am ready now to just start kind of canceling out the work and things that are the same on both sides. So I am going to cancel out my 10 electrons there, and I'll cancel out the 10 electrons here. Maybe I'll just zoom in, make it a little bit easier. And then I had 20 hydrogen ions there and 12 here. So I can actually subtract out 12 from both sides, and that brings me down to 8. And for waters, I have 6 and 10. So I can subtract out 6 from both sides, and that leaves me with 4. So now I'm going to finalize my answer. Or at least I'm going to try to give you a preview of some of the other work. Okay. So I have 8 H plus aqueous plus 5 PbO2 solid, and I'm getting that from the original information, plus I2 gas gives me 2 IO3 1 minus, and all of those, anything with the charge is going to be aqueous, plus 5 Pb 2 positive aqueous, plus 4 H2O liquid. Again, we'll go back and just kind of double check charges and make sure that those all worked out for us. So we get a positive 8 here, plus a 0, plus a 0, coming from there, and there, and there. And that's going to give us a positive 8 on this side. And then over here, I get a 2 times a negative 1, so negative 2, plus 5 times 2 positive, so 10. And that comes from there. And then this is going to contribute a 0. And that's going to give me a positive 8. So just checking the charges of this, both sides balance, and this should be my correct answer. Again, if I have more time, what I would do is I would go back and just double check my atoms. But oftentimes when you're doing problems like these, especially in an assessment situation, you don't always have time to go back and check your actual atoms, and you're just hoping that you didn't make a mistake. But if you have time, definitely go back.